Okay, guys. What we got today? Okay, guys, we're going to give everybody a few more minutes to get logged in just in case. So sit tight. We've only got 8 people so far, 7 people. So we'll start in just a few minutes, okay?
We're doing 6.5.
Yes. Um, yeah, 13. Okay, guys. Let's see here. Get this all set up. So, a couple things. Number one, there we go. Let's see here. Let me just get and then done real quick. Got it. Okay. All right. So a couple things real quick. Number one, at the bottom of your screen in your little black bar, there should be an icon that says participants. So if you click on that, for those of you that weren't in the meeting last week, it will give you there should be a little blue hand that says raise hand. So if you click on that, then it will show up on my list that you are raising your hand, and I can let you ask a question if you have a question. So if you want to ask a question, you can just click on the raise hand, and I will see that on my screen so I know that you have a question. If you type it in chat, I probably won't see it because I don't have my chat window opened up. So the raise hand option would be the best way to do that, okay? And then you just need to turn your microphone on, ask your question. Be sure to turn your microphone off after you finish so we don't hear all of your background noise. And yeah. All right, so we are in 6.5 today. So I'm going to go through the lesson. At the end, I will add, give you guys a little bit of information that you might need to know, that you might be wondering about, like about quizzes and tests and things like that. You should have gotten 2 emails. This one, the one that gave you the code for this meeting, which obviously you got. And the other one has the code for the office hours and a list of when office hours are. So be sure to take advantage of office hours and log in if you have questions or need help with that. Yeah, that's pretty much it on office hours. All right, any questions before we get started? Okay, I don't see any. So again, if you have a question, click the little blue, raise your hand, and we'll stop and take a look at that. All right, so the good news is we have finished all of the what do I want to call them? Identities from your worksheet, from your formula sheet. Let me just take a quick glance back there. So on your formula sheet, the identities for this section, so sections 4, 5, and 6, are just the product to sum and sum to product identities. So you may still have maybe once or twice see a problem where you have to use one of those plus apply something from the first 3 sections. But for the most part, those are the only identities for this part of the test or of the chapter, okay? And then you've got the sums in the form of a sine x plus b cosine x. So that was when we did the equations at the end of section 4. So no new identities for this section or the next section. So hopefully that's good news for you guys. Let's see, I'm not sure who just logged in. Somebody did. Anyway, for you guys that just logged in, if you open up the participant window at the bottom of your screen, there's a place for you to click and raise your hand, and that's what we're going to use, that option if you have a question. Okay? Anybody not see that option on their screen? Great. Okay. So section 5 is inverse trig functions. We've already used this a little bit in previous chapters. So this is the part on your calculator, which is let's see. No, do that. There we go. So this is the function on your calculator, which you have as sine to the -1 or cosine to the -1 or tangent to the -1. Okay. We're going to look at that a little bit and go through these in a little more detail. So here is the sine function, just a graph of it. And basically, for any function to have an inverse, it either has to be continually increasing or decreasing. And the test we can use for that is the horizontal line test. So if a function is continually increasing or decreasing, like a linear function is either constantly going up or constantly going down, depending on the slope, then if we do the horizontal line test, which basically says if you draw a horizontal line, I'm going to use a dotted line, then that line should only intersect the graph at 2 points. So you can see here, this horizontal line intersects at several points, actually here and here and here and here and here. So that means that the sine function technically has no inverse because it fails the horizontal line test, okay? But of course, we already know it does have an inverse because we've been using it. So what we're going to do is we're going to limit the function. So if we limit the function to just this section right here, and that is from -pi/2 to pi/2. We just have this one curve here. In that section, anywhere I move this horizontal line up or down, it's only going to come in contact with 1 point. Okay, so that's basically the idea behind inverse trig functions. Is we're not using the entire function, we're only using a certain portion of the function to get the inverse. So let's think about this, and you guys we'll go through some of the other notes in a minute. This part right here from 0 to pi/2, that is the first quadrant. And this part over here from 0 to negative pi/2, that is the fourth quadrant. Okay, so anywhere in the fourth quadrant or the first quadrant, we can use those values for the sine to find the inverse. Okay, that's basically what you got on the rest of that page. So if we limit the domain from negative pi/2 to pi/2, then we can get the inverse. So that means from that point, again, if you look at your graph, let's see, let me get a little piece of the graph here. And scroll back up there. There's my scroll bar. Oh, that's cosine. I want sine. My board is being a little tricky here. Okay. Oh. What is wrong with this thing? This is in the way. Give me just a minute, guys. I don't know why this thing is being so picky. Right this way. Okay. So if we take just this portion of our graph, I got a little bit too much, but you get the idea. So you can see on here, the highest point is at, so we're really between this point and this point. So the highest point is at 1. The lowest point is at -1. So for our function, this is the domain and range we're going to use for sine. Okay, so the domain is from negative pi/2 to pi/2. The range, which is our y values, is from -1 to 1. So that means our inverse, which is what we're looking for the inverse, you just switch the domain and range. So now our domain for the inverse, this is for sine to the -1, is from -1 to 1, which means if we're doing the inverse sine, we can't plug that into your calculator unless you have some value between 1 and -1. So for instance, if you have your calculators out, you put in the inverse sine of 3, it's going to give you an error because, again, sine doesn't go above 1 or below -1, so we can't do the inverse of 3 because there's no value that we can take the sine of that's going to give us 3. Okay, and when we do that, again, our range or our y values, the answers we're going to get are going to be between negative pi/2 and pi/2. Okay, so this is another one of those that you need to pay attention to the question. You can see the range here is in radians, but if the question is in degrees, or if it tells you to answer in degrees, then you need to make sure you set your calculator for degrees and answer in degrees. Okay, so basically we're going to be finding the inverse sines of several different functions. And again, the value we're looking to find the inverse sine of needs to be between -1 and 1. Otherwise, there's no solution. Okay. All right. So let's look at a couple problems. So inverse sine of radical 3/2. So if you remember that this is one of those on your unit circle, so you could take and look at your trig sheet. Just remember, you'll have your calculator. You won't have your trig sheet on the test. But anyway, this is positive. So remember, let's go back to our little graph here. In the first, second, and third and fourth quadrants, so everything is positive here, sine is positive here, tangent is positive here, and cosine is positive here. So we're limited to, for the inverse sine, these two quadrants. So if we're taking the inverse sine of a positive number, that means we know we're in quadrant 1. If we're taking the inverse sine of a negative number, that means we would have to be down here in quadrant 4. So pay attention to which quadrant you're in. So again, you're going to get angles either in quadrant 1 or in quadrant 4. Okay. So Inverse sine of 3 pi over, or radical 3 over 2. Again, you could put plug it in your calculator or go to your trig sheet. That's going to give you pi over 3. So the angle, again, the way you would think of this is the angle that has a sine of radical 3 over 2 is pi over 3, or again, that would be, if we were in degrees, 60 degrees. Okay. Number 2, arc sine. So remember, arc sine is just another term for inverse sine. So the arc sine of 1/2, again, this is positive. So we are in quadrant 1. And the angle that has an inverse sine of negative 1/2 is pi over 6. Okay. So all we're doing is just basically plugging it in your calculator and getting the answer. Okay. And just remember which quadrant you're in. All right. So number 3, the arc sine of negative 1/2. So again, this is the inverse sine of negative 1/2. So we will be in quadrant 4 because it's negative. So when you put this in your calculator, the answer it's going to give you, if you're in radians, is this. Okay, which is correct, except remember, when you guys are doing this, we want positive angles between 0 and 360, or positive angles between 0 and 2 pi. So to get our actual answer, you would want to do 2 pi minus pi over 6. And if you simplify that, you're going to get 11 pi over 6. So make sure your answers are positive angles, again, between 0 and 360. All right. Any questions on sine? Okay. All right, cosine is the same thing. We need to limit the cosine function, but again, we want to be between 1 and negative 1. So when we do cosine, we're actually going to limit it between 0 and pi in order to get our function that has an inverse. So the range or the domain for our cosine function is going to be 0 to pi, which gives us a range of negative 1 to 1. So the domain and range for the inverse function would be between negative 1 and 1, and our solutions are going to be somewhere between 0 and pi. Okay. So that means, again, just as a reminder, our angles, so let's divide this up right here. So this first half of this, where the values are positive, this is the first quadrant. Over here where the values are negative, this is the second quadrant. So your answers for this are going to be in quadrants 1 or 2. Okay. All right, and tangent, same thing. We need to limit tangent because, again, tangent continues on, and if we use the whole entire tangent function, we would not be able to have an inverse. So tangent, if you think of the tangent graph, you have that somewhere in your notes before. I'm sure you could look back on that. The domain on the tangent is going to be between negative pi over 2 and pi over 2. And remember, tangent goes on to infinity, so the range is actually all real numbers. Okay. All right, so let's look at some examples. Well, these are just more of the same examples. So, any questions so far? I'll make sure you guys are getting this. Okay, so as long as you have a fraction or a whole number, you should get one of the reference angles. So you can see in these 3 examples, we got a fraction, we got a radical, we got another fraction. So if we do the inverse cosine of 1 over radical 2, so if we want to simplify that, this is the inverse cosine of radical 2 over 2, which is more along the lines of what we're used to seeing. And again, it's positive, so we are in quadrant 1. And if you do that, you're going to get pi over 4. or 45 degrees, depending on what how the question is asked. Okay. For tangent, again, we're positive, so this is quadrant 1. And if you put in the inverse tangent of radical 3, you're going to get pi over 3, which is 60 degrees. And finally, the inverse sine of radical 3 over 2, again, we're in quadrant 1 still, we would get pi over 3 or 60 degrees. Okay. So all of these, again, when you have either a radical expression or a fraction expression, you're going to get one of your reference angles, just like we did with all these. Okay. If you've got a decimal, however, you are going to get decimal degrees or decimal radians, depending on how they're asking you to solve the question. So you can see here, if I do the inverse cosine of negative 0.647, here it is in degrees, and here it is in radians. So again, it's negative, which means we're in quadrant 2. Keep that in mind. Make sure you know which quadrant you're going to be going to, whether it's positive or negative. And then, so here we have tangent. So the inverse tangent of negative 8.65, again, here is degrees and here is radians. So for sine and for tangent, if you're negative, you're going to get a negative measure. So remember, you need to convert that to a positive value by either adding 360 or adding 2 pi, depending on which one it is. Okay, so keep that in mind. Cosine, you're going to get the exact angle every single time, because cosine is first quadrant and second quadrant. You're going to get something between 0 and 90 and 90 and 180. But because tangent and sine give you a negative angle that's in quadrant 4, you're going to have to either add 360 or add 2 pi. So keep that in mind when you're doing this. All right, and this last one, anybody want to raise their hand and tell me what the answer is going to be here? Nobody? Come on. The inverse sine of negative 4. It's an easy one, guys. I have a whole list of names in front of me. I can just start calling names. I knew Hunter would be the one. Hunter, what do you got?
Is it a domain error?
Well, you could say that, or so what does that mean the answer is?
DNE or
Right.
DNA?
Does not exist, or just no solution.
Yeah.
So remember, the value you are taking the sine of, Hunter, make sure you put your hand down. The value you're taking the sine of has to be between negative 1 and 1. So since we're taking the sine of negative 4, or the inverse sine of negative 4, there is no solution. Again, we would say this is not between negative 1 and 1. So watch that carefully. That should be a 1. Let me get it right now. Nope. Well, I got to do like that. Yeah, there we go. So make sure you pay close attention to that, because I have seen some people that they just plug it in and they think they have it, and they think their calculator's giving them the wrong answer, so they write IDK or something silly like that on their test. If it says error, then you probably did it right, because there's no solution, right? Okay, so we are going to combine these together, okay, with other functions. So let's take a look at that. Any questions so far? Okay. All right, so example 1. Here we're doing the cosine of the arctangent of 2. And again, if it helps you guys to rewrite this, this is the inverse tangent of 2. So remember, tangent goes to infinity. So don't say, oh my gosh, I can't do that. It's over 1. No, tangent is okay. All right. So remember, tangent of 2 is the same as the tangent of 2 over 1, or the inverse tangent of 2 over 1. So what we're going to do with this, remember, tangent is sine over cosine, or y over x. That means y is equal to 2, x is equal to 1. Okay, and we need to find r. So r squared is equal to, well, let's just do r. R is equal to the square root of x squared plus y squared. So Pythagorean theorem. So r equals radical 5. Okay. So it doesn't matter what angle this is, because whatever angle that is, we'll call it alpha. We're going to take the cosine of it. So over here we have the values for alpha, the x, y, and r values for alpha. So if you plug this in your calculator, you're going to get some crazy decimal, which isn't really going to help us, because we want to find, when, and the directions for this should say find the exact value. Sorry. So I need to add that to the notes. So if all of this is equal to alpha, then we're actually taking the cosine of alpha. Well, we got all the measurements over here for alpha, and we know that cosine is equal to x over r. So x is 1, r is radical 5. And if we simplify that, we get radical 5 over 5. So the cosine of the arctangent of 2 is equal to radical 5 over 5. Any questions? Okay. So again, make sure you pay attention to what quadrant you're in. That one's not a problem. When everything's positive, so 2 is positive. And again, we can only be with tangent. We can only be in the first quadrant or the fourth quadrant. So some of you might be thinking, oh, well, but this could be 2 over 1, or it could also be negative 2 over negative 1. Well, no, it can't be that, because that would put us in quadrant 3. And we can't do the inverse tangent in quadrant 3. Okay, so it has to be positive 2 and positive 1. So since this is positive, we're in the first quadrant, which means we're taking the cosine of an angle in first quadrant. Everything in first quadrant is positive, so our answer is going to be positive. Okay. However, take a look at the second one. So we need the tangent of the inverse sine of negative 3/4. So negative 3/4 puts us in quadrant 4. So sine and cosine, or sorry, sine and tangent, when they're negative, is going to be quadrant 4. Cosine will be quadrant 2. All right, so make sure you remember those. So same thing here. Sine is, what is sine? Sine is y over r. So y is negative 3, r is 4. Remember, r will always be positive. So 4 squared has to equal x squared plus negative 3 squared. So if you solve all this, we're going to get x squared equals 7, and that means x equals radical 7. Okay. So we've got the tangent of alpha, whatever this is. Well, here's our values again. These are our values for alpha. We've got x, we got y, we got r. And so the tangent of alpha is equal to y over x, which is going to give us negative 3 over radical 7. And if we simplify that, we get, oops, negative 3 radical 7 over 7. Okay. So when they're asking you for the exact value, you're going to use your Pythagorean theorem values, your x, your y, and your r, and find the values of that. Okay. Okay, so these are nice because there's no variables. However, sometimes we might have a variable. So take a look at one with a variable real quick. Any questions so far? I kind of hit my participant list. No questions? We're good? Okay. All right, so if you notice here, we're doing the cosine of the arc sine of 2x. Well, we know 2x is our value, and it has to be between -1 and 1. Okay, so if we plug that in, so basically, again, it's positive as far as we know. So that means 2x has to be less than or equal to 1. If we solve that for x, then x has to be less than or equal to 1/2. Okay, so x is somewhere between 0 and 1/2 because we're in quadrant 1. All right. So if we use that idea, let's see. Why do my notes look weird? Oh yeah. So basically, we're doing the cosine of the inverse sine of 2x over 1. So again, sine is y over r. So y is equal to 2x, r is equal to 1, and we can plug those in Pythagorean theorem to get the value of x, because we need that to find out cosine. So 1 squared is equal to x squared plus 2x squared. So that's our value for y. Let's call this b actually, instead of x, so don't get them mixed up. I'm going to call this b squared, because we don't want to combine this together. So b squared is equal to 1 squared is 1, so we got 1 minus 4x squared. So our value for b is going to be the square root of 1 minus 4x squared. And because this is being subtracted, we can't pull out the 4 or pull out the x squared. You just need to leave the whole thing in the radical. Okay. So for this one, it's kind of a weird one because we have an x in our function. So as far as your triangle goes, if you're thinking of your triangle for Pythagorean theorem, I would think of it more as A, B, and C. And A is your value. Well, we did it backwards, didn't we? We put D over here. So you think of it like that and use A, B, and C instead of X, Y, and R. Okay, just so you don't get confused. Okay, so we've got B, the cosine of alpha, and again, this, whatever value we would get from this would be our alpha, is equal to x over r, or actually phi over r. So this is equal to the square root of 1 minus 4x squared all over r, which is 1. So we just say 1 minus 4x squared. So if you have a variable in your amount that you're taking the inverse sine or inverse cosine or inverse tangent of, then you're going to get something in a radical with a variable in it similar to this. You won't see too many of those. It'd be very rare, but occasionally it might come up. Okay. All right, any questions? Okay. All right, so sometimes, occasionally, your two values might cancel each other out. Go away. So you can see here, we're taking the sine of the arc sine of 2x. So basically, we want the sine of some angle whose sine is 2x. So if we did the inverse sine, we would get some sort of angle, alpha, we'll call it. So basically, we're taking the sine of alpha. Well, we already know the sine of whatever that angle is 2x. So this is equal to 2x. So basically, in this problem, the sine and the arc sine are going to cancel each other out. So we're finding the sine of some angle. Well, we already know the sine of that angle is 2x, so the answer is 2x. Okay, so occasionally they will cancel each other out. Right? Number 5, very similar, except now we got cosecant. Well, cosecant is 1 over sine. Okay, so it's kind of like number 4, except we're doing 1 over sine. So the sine of some angle, which is 2x, if we do the inverse sine, we're going to get that angle, and then we're going to do 1 over the sine of that angle. So this would be equal to 1 over the sine of that angle, which is 2x. Okay. All right, and number 6 we're going to skip because we're not going to mess with that. It's too complicated, and we're not doing it on the test anyway, or the homework. All right, let's see. I should have one more. Yeah. Okay, so take a look at these real quick. So what's going to happen with the first one? Well, again, if we take the sine of 45, the sine of 45 is radical 2 over 2. So we're taking the inverse sine of an angle that gives us radical 2 over 2. Well, that angle is 45 degrees. So again, here, the arc sine and the sine cancel each other out. Okay? But now, they're not going to cancel each other out. Anyone want to take a wild guess why? So if you put this in your calculator, the sine of 135 is going to give you negative radical 2 over 2. That part of it is good. But when we do the arc sine of negative radical 2 over 2, what are we going to get? Are we going to get 135? Can we get 135? That's the real question. Is it even possible to get 135? Hopefully y'all are thinking no, because remember, if we do the inverse sine, where does that have to be? It has to be either quadrant 1 or quadrant 4. 135 is in quadrant 2. Okay, so if you look at this and say, oh yeah, that's really simple, these just cancel out, you're going to be wrong, okay? Because again, if we take the sine, we're going to get negative radical 2 over 2, but then when you do the inverse sine, you're going to get negative 45 degrees, which is, what is that, 315? No. We're going to get that? No, we're not going to get negative. Why am I saying negative? Yeah, there we go. Yeah, there shouldn't be a negative there. Sorry, guys. We're going to get just 45 degrees. So the sine is positive in quadrant 2. So even though our angle is in quadrant 2 and it's positive, when we do the inverse sine, we're going to get 45 degrees because, again, the arc sine is limited to quadrant 1 and quadrant 4. So the only time they're going to cancel out and cancel each other out is when the angle meets your domain for your function. Okay, so if it's in quadrant 1 or 4 for sine, then you can say, okay, they cancel out, and there's your answer. When it's not, and we've got this situation, and we're in actually quadrant 2, then you've got to actually do the calculations separately and not just cancel them out. All right. Any questions so far? Yes, Hunter.
Okay, I'm a little confused from example number 5. I'm not exactly sure how you got 1 over 2x.
All right. So let's go back up here to this one. You see that one? Number 4? Okay. So number 4, we said that we're taking the sine of the inverse of some angle that equals 2x. Okay. So the sine of an angle whose sine is 2x. So whatever angle that is, when I take the sine of it, so this is going to give me some angle, call it alpha. When I take the sine of alpha, I'm going to get 2x. You good with that? Okay. Over here, it's the same thing, except I'm doing cosecant, which gives me the 1 over the sine. So when I plug this in, I'm getting some angle. Okay. I should actually put an alpha here. So this is giving us alpha. The inverse sine of 2x gives us an alpha, just like we had up here. When I plug that alpha in here, the sine of that angle, 2x. But because it's cosecant, it's the reciprocal of that, so the answer is actually 1 over 2x.
Okay, yeah, that makes sense now. That wasn't making sense for a minute, but that I get it now.
Okay, great. Okay, guys, any other questions on this section? All right, perfect. So let me go over a couple other things besides other than these. So the 2 things we still have to worry about are the quizzes and the tests. So here is the plan. Well, first off, let me say, so your homework assignments, I have updated all of the homework assignments. They are all on WebAssign with new dates. So ignore the sheet that you had from before that showed any due dates at all. Just forget about those. Just follow the due dates listed in WebAssign. Okay. Yeah, I just need to get a copy of attendance here again, since a couple more people signed in. Let me finish that real quick here, guys. Okay. So all those are still there, and you got that. For those of you that didn't see, let's see, let me look at WebAssign real quick here. I think you got the assignment that from the first section, from section 4, I actually extended that, I believe, to be due today, maybe. So if you haven't done it yet, you still have time to do it. Yeah, 6.4 is due today. So that's the one we did before break, before we left. So if you haven't done that one yet, you still have time to do that. Okay. All right. So for quizzes are going to be a little bit different. First off, there are going to be fewer problems. Okay. Just because 5 or 6 problems on a quiz or whatever, just too much. And we're going to do quizzes 1 of 2 ways. We're either going to do it as a poll on Zoom, so I can do like polling questions, or to see if that you guys are understanding things. But we're going to use that for quizzes. So the quizzes we do on WebAssign will be multiple choice. I'll put up a problem or 1 or 2 problems and let you just solve it and then put in your answer. That's one way to do it. The other way is we will do some of the quizzes on WebAssign. So the way those will work is when class is finished and you guys log out, then you'll need to log into WebAssign and you'll have like 15 minutes to finish the quiz. So it's going to be a time quiz. It'll only be available for a certain amount of time. And what you will do with those, and we'll go over that later this week, basically you'll solve the problem, put your answers in WebAssign. It's not going to tell you right away if they're right or wrong, so you'll just have one chance to put in your answer. Well, maybe we'll do two. We'll see. But then you're going to have to take a picture of your work and email that to me. Okay. So that way I can check your work and make sure you're doing it right and give partial credit and those kind of things. Again, the quizzes are only going to be probably at the most 3 questions. And so that you guys have a little bit more opportunity to bring up your quiz grade overall, your average on quizzes, we will probably have maybe more than 1 quiz for each section or each chapter. So there'll be probably between now and the end of the semester, we'll probably have a total of 4 quizzes left. But again, they'll each be probably 2 or 3 questions, not 5 or 6 questions. And I'll still probably do at least 1 or 2 extra credit questions for that. Okay. Tests, I haven't. We're still working on figuring out how the tests are going to work. So for now, don't worry about it. Just focus on your homework, and I will let you know probably by the end of the week what's going to happen with the test. Okay. And then finally, you should have gotten a second email with office hours. So I've got it set up for 2 hours each day on Monday, Tuesday, Wednesday, and Thursday. So those are times when you can just log in and ask questions. Okay. It's open to all my students, so there may be 2 or 3 other people there at the same time, but you can ask questions. I can work through questions with you and show you on the screen just like we do with this. And that's, again, open at any time. If you need to discuss grades or anything individually, you can send me an email and I will set up a time where we can have a Zoom meeting just with you and me, and we can talk about your grades or whatever else you need to do. Okay. So if you haven't looked at your grades recently, make sure you do that so you know where you're at, so there's no surprises. If you need to discuss grades, make sure you get with me. Don't wait till it's too late. We still have several grades left, but again, if you're not staying on top of it, it could easily get ahead of you and end up being a bad thing. So keep an eye on that. As far as the final exam, we are discussing what we're going to do with that as well. So we may do a shorter version of the final or something a little bit different than our typical final. So as soon as I have that all figured out, I will let you know. But I don't want to just say, there's no final, because again, that's another grade that could help several of you bring up your test average on that. So we'll get that information and let you know as soon as possible. Okay. All right. Any questions? All right. And finally, always, if you have a quick question or something and you want to hang out after class and not log off, you can do that and ask me questions at the end of class after everybody's logged off or whatever. So your choice, whatever. All right. Oh, and finally, I forgot. These classes are being recorded. So I'm going to post the videos of this or the recordings, so you guys can use them to go back and watch them again or whatever if you need to. So as soon as I get that all set up and going, I will post in the announcements on WebAssign where the recordings are going to be, or the link to the recording or something like that. So keep an eye on the announcements in WebAssign. That's on the right side of the page, right across from your assignments. And I will have the information on the videos in the next, probably by tomorrow. Okay. All right. So any other questions? You can hang out. Otherwise, we will see you guys later. Have a nice day. See you guys Wednesday.